So previously we know that this is the f of x from the partial fractions part, and now we are integrating this then. So first of all, we can move this 3 here, so it's 3 times 1 over something. And for the minus x over x squared plus 4, so actually this is the actual fraction here. Okay, so it's actually just minus x, so actually this is the fraction. So if we separate this part, we have, this part, we have minus x divided by x squared plus 4, just like this. But if you look at the MF19 formula, there's no way we can integrate this unless we are using this rule. Now if we want to use this rule, we gotta make sure that the numerator is the derivative of the denominator. So f prime means the derivative. So in order to integrate this, we have to make sure that the numerator is the derivative of x squared plus 4. The derivative of x squared plus 4 is 2x. That's why we modify this. We multiply by 2, but we also divide by 2, so we're not changing anything actually. But this is now now we can integrate this using this rule. Okay, so again, the numerator must be the exact derivative of the denominator. And from this part of the fraction, 3 times x squared plus 4, we can just write the 4 as 2 squared, because we're going to use this rule here. X squared plus a squared, we have to identify the a. Right, now we can integrate. So this 3 is a coefficient, just rewrite. The integral of 1 over x is ln x from here. So we have ln, the denominator, but we divide by 3 because of the chain rule, because of the derivative of the argument of the logarithm. So for this guy here, we can just use this rule. It's just ln the denominator, that's it. So it's ln the denominator, and there's no need to use chain rule or something here. Okay, so from here we apply this rule. We have 1 over a, the a is 2, so 1 over a inverse tangent x over a. So now we plug in 2 and 0. After we simplify, this is just ln 3x plus 2, and this is just 3 over 2. And now we plug in 2, plug in 0, subtract. So plug in 2, plug in 2, plug in 2, plug in 0, plug in 0, plug in 0, and we subtract. So since we need the exact value, we don't want to use ln in the calculator. So there's nothing you can simplify here, just do this one here. Okay, this is 6 plus 2, which is 8, that's what we get. Okay, so we don't use ln in the calculator, just use your calculator for this part if necessary. And same thing here, don't use calculator for the ln, just use the calculator for 2 squared plus 4, which is also 8. And from here we can use calculator for the whole thing. We have 3 over 2 times pi over 4. And remember, there's a minus, so minus times this guy, so that's minus ln 2. And minus times minus, so it's gonna be plus 1/2 ln 4. And this is actually 0. So now we use the power rule. We move the power inside the argument. We have 8 to the power of 1/2, and this is 3 over 8. And we move the power here again, 4 to the power of 1/2. To the power of 1/2 means square root, so this is also square root. And now we combine the ln's. So subtractions becomes addition, and subtraction becomes division, and addition becomes multiplication if we combine the ln. So in other way, just put the plus in the numerator and the minus in the denominator. So here this is plus ln 8, so put it on top 8, and this is also positive, so also on top. And this is minus so it's below the division line, minus below the division line. Okay, so that's a faster way to multiply and divide when combining logarithms. So use your calculator for this part. You're gonna get 2 root 2, and 2 root 2 is actually 2 to the power of 1, 2 to the power of 1 half, so it's 2 to the power of 3 halves. So we bring the power out of the logarithm, we get 3 ln to 3 halves ln 2 plus 3/8 pi. That's the final answer, and you can leave it at this. Right, I'll see you guys.